Greetings, math fans. All right, so this is day 5, chapter 1. It's actually our last day, and we are going to talk about inverse functions. And the cool thing is we're actually going to use parametrics now because we've spent the past 2 days talking about parametrics and how to convert from a Cartesian equation to a parametric and vice versa. And so now we're going to actually show an application of parametrics. So it's kind of cool. Okay, so again, inverse functions are our topic, and I said to find the inverse of a function, you basically just swap the x and the y, and then you resolve for y. Okay, real simple. Just swap the x and the y. So if I actually had just to do a quick example, just if I said like y is equal to 2x plus 6, it would just define the inverse would be x equals 2y plus 6, and then I'd solve for y. So I'm going to subtract 4. So you get 2y is equal to x minus 4, and then divide by 2. So the inverse of this function with y is equal to x over 2 minus 2. That would be the inverse. Okay? So we'll talk a little bit more how you even can tell after you graph it if it's an inverse or not. So it's kind of cool. Okay. So a couple things here. First, it says important. This is pretty significant here. It says the domain of the inverse is the range of the original function. So the domain of that inverse function is the range of that original function, and vice versa. The range of the inverse function is the domain of the original function. Okay, so they just swap. The domain and the range, they swap values for the inverse in the original function. Okay, that's pretty interesting. It's actually kind of cool. Okay, so let's just start out with some problems here. And we're going to use our graphing calculator a little bit, so you might want to get that out. And I have an emulator here for the graphing calculator, so hopefully this all works out well here. Okay, so it says find the inverse algebraically. For number 4, find the domain and the range for both the original function and its inverse. So this is pretty easy. I know it's in terms of f of x, but I'm going to write it in terms of y, so it's easy to write it. So y is equal to x to the 5th plus 5. And then I'm going to say x is equal to y to the 5th plus 5. And then subtract 5, so y to the 5th equals x minus 5. And then I'm going to take the 5th root of both sides. So y is equal to the 5th root of x minus 5. So that, math fans, is the inverse. Now, let me just kind of show it on the graphing calculator here. We're going to graph both of these. Let me just move it over just a little bit so we can see everything here. Okay, so we're going to do y equals, and we're going to graph x to the 5th power plus 5, and the 5th root. So you can use, I like to use to the 1/5 power, I guess. So let's do that. X minus 5 raised, and you got to put this in parentheses, to the 1/5 power. Okay. Enter. All right, so then I'm going to graph, since we're swapping the x and the y, I'm just going to tell you this. I'm going to have you guys see the symmetry here. We're going to graph y equals x. And so by swapping the x and the y, we're going to actually show that it is symmetrical about y equals x because we are swapping those two. So watch this. We do zoom 6. It's a little choppy here. Okay, but oh, look at that. It's kind of cool. Okay, so we graphed the first one, a nice little exponential function, right, or to the 5th power, right? So it goes up fast. That's the one that went kind of straight up a little bit, and then it graphed the next one, which is the 5th root. So that's why it's more horizontal. And then if you look at the y equals x. And then you look at the other two graphs, it's symmetrical, right? I can fold it over on y equals x and it has symmetry. So anyway, I thought that was kind of cool. Okay, so let's do the next one here. So notice, math fans, there's a restriction on this one, right? It's the restriction here is just x has got to be greater than 0. Okay, so let's go ahead and write this out as y is equal to 4 over x squared, and then we'll swap them. So it's x equals 4 over y squared. So I'm going to cross multiply x y squared equals 4 divided by x. So y squared equals 4 over x, and then I'm going to take the square root of them, and I get y is equal to plus or minus 2 over the square root of x. All right, let's rationalize it. So y is equal to 2 square root of x over x. And we don't even really need to rationalize, it's not that big of a deal. Okay, so and notice x was greater than 0. This is pretty important. X was greater than 0. And so we're going to make this, instead of being plus or minus, it's just going to be positive. Okay? All right, so let's go ahead and graph it. So this is this one right here. And of course, the original function should be, they should be inverses of each other, okay, when we graph it. And again, it's x is greater than 0, and so, you know, you were graphing the positive part of the, after you take the square root. So let's bring up the virtual TI here. I cleared this out already. So it's going to be 4 divided by x squared. And the other one is going to be 2 times the square root of x. Kind of cursor over a little bit, divided by x. If you didn't rationalize it, it would give you the same thing, right? Should. Okay. And then we're going to do y equals x as well. Okay, let's go ahead and graph that. So 4 over x squared is going to be, and then actually I'm going to set my window now because I did restrict it. So x is greater than 0. So as opposed to putting 0 in there, because 0 is not a good number, I'm going to put 0.0001. And I'm going to put a max value, because I did this already, and I always want to make sure it looks kind of good, to 5. And we'll do that for the same thing for y. 0.0001. And y max is 5. Okay, so let's go ahead and graph this baby. Okay, the first one being, there's the 4 over x squared. There's the next one, and oh, look at that, man. Oh, it's so cool. See, you can see how it's symmetric, you know, folding across that. It's kind of cool, pretty cool. Okay, all right. Let's move on to the next one here. So y, it's already y equals, so I don't need to do anything with that. Okay, so let's just do x equals, let's swap it right away. So it's x equals y minus 4 over y plus 3. So we're going to cross multiply, so it's x times y plus 3 is equal to y minus 4. So a little more difficult to solve for this one, right? You guys agree? But not a big deal. So we're going to distribute, so we get xy plus 3x equals y minus 4. And then I'm going to subtract the 3x and subtract 3x from both sides. And subtract y. So basically I'm getting the y's on both sides, or on the same side, because then I'll be able to factor it out. So you get xy minus y is equal to negative 3x minus 4. And then I'm going to factor out a y. So y times x minus 1 equals negative 3x minus 4. And my last step is divide by x minus 1. So I get y is equal to negative 3x minus 4 over x minus 1. So that, math fans, is the inverse. Now you're like, no way, man. Is it really the inverse? But again, let's just try and check it out. It's kind of cool. Okay, so let's clear these out. I'm just going to clear the first two out. I don't need to clear the last one because we're going to graph y equals x. Okay, so it's, make sure you have lots of parentheses. X minus 4. Oh, I lost my y equals. Sorry. Parentheses. There we go. X minus 4 divided by x plus 3. Okay, it's the first one. Hit enter, and then do the next one. So it's going to be negative 3x minus 4 divided by x minus 1. Okay, and then I already have y equals x in there. So let's go ahead and graph it. Oh, I should do, here, you know, that's that, no way, it's going to take a second here. Let's do zoom 6. Zoom 6. There we go. Okay. It's a little slow, but that's kind of cool. There's the other function. And there it is. You can see it's symmetrical. Cool stuff. Okay. All right. So the last one I'm asking you guys to do is asking you guys to do this next equation, but also do the domain and the range. Okay. So the first thing I want to do, it says the left half. That's pretty important. So the left half means we need to find the vertex, which is really easy because this is in vertex form. It's negative 3, negative 4. Okay, sweet. So x equals y plus 3 squared minus 4. So I'm going to subtract 4, so I get y plus 3 squared equals x plus 4. Take the square root of both sides, so y plus 3 equals plus or minus the square root of x plus 4. So subtract 3, we get y is equal to negative 3 plus or minus the square root of x plus 4. Now remember, guys, it was the left-hand side, which is the negative side. You guys agree? The negative side? So we'll keep the negative. So let's erase that right there, and we'll keep the negative. So that's what it is. Y is equal to negative 3 minus the square root of x plus 4. Okay, so let's go ahead and graph this one too, and then we're going to do the domain and the range in a second here. Okay, so let me bring up the TI. Let me move this over a little bit. Okay, so we're going to clear that. Clear that. Okay, so I got this cleared already, and we're going to do y is equal to x plus 3 squared minus 4, and then negative 3 minus the square root of x plus 4. Okay, we already have y equals x in there, so I can graph this one. Actually, I'm just going to do zoom 6. So notice what we have here is I graphed this whole parabola, x plus 3 squared minus 4, because you can't just do a window just for that individual parabola. And I did the left hand. So if you look at the left hand here, math fans, let me move this down a little bit. But the left hand is this part right here, right? The left-hand side of the vertex. And if you notice that it is symmetrical with this one right here. And maybe the symmetry doesn't look all that great. And part of the deal is because of the scaling of this. If I actually did zoom square, now it actually looks, if you kind of look at it, it actually looks more symmetric. Zoom square just makes because it's a rectangle screen, and it makes it look a little bit better. It makes it more into a square screen to give you a good look. Okay, so That's it. Now the only thing I need to do here, math fans, is I need to come up with the domain and the range. Okay, so let's do that. And let's do we got the original function. The original function, the domain. It's the left hand. So it's from -3 to, really negative infinity to -3. So negative infinity to -3. Okay. And then the range, do you guys agree the range you're going, if you'd graph it, you're going to graph -3, 4, and then it goes up. So it's going to go from -4 up. So the range is from -4 to positive infinity. Okay, so let's look at the inverse function. The inverse function, without even looking at the original function, because we're going to compare them in a second. Do you guys agree that the inverse function is that can't be a negative under the square root? Everybody agree with that? So that basically can be -4, which gives you the square root of 0, but it can't be -5. So it actually, the domain is -4. And it goes to infinity, right? It keeps going up. We'll talk about the parentheses and brackets in a second. And the range is it's going from -3, and because it's subtracting a number, the biggest value can be is -3, and then it's getting less and more, lower and lower and lower, -3, -4, -5. So that means it's going to be negative infinity to -3, which actually is just really cool because it does match up with this. And some of you might be saying, well, Mr. Curvis, well, one of them has brackets, one doesn't. Yeah, but I said like left hand, so sometimes people say, well, with a bracket, because what is that? Is the vertex left hand or right hand? Maybe it's both. That's not really a big deal. But the big deal is that you can even see by creating the functions and then looking at the domains and the ranges, they swap values. It's kind of cool, okay? But that's really important, just to know that they swap values. The domain and the range swap values from the inverse to the original function. Very, very important. Okay. So the next part, it says use parametrics to find the inverse. Write f of x, f inverse of x, and y equals x parametric equations, and then graph all three on the graphing calculator. All right. So basically, you have, they ask you to write them as parametric equations, all of them. So let's do the f of x. That's going to be, I'm going to put a colon here, not a what, equals. So y is equal to 5x minus 3. So if I want to parameterize that, which is really easy, remember, y equals 5t minus 3 and x equals t. It's really easy to parameterize equations, guys. It's really easy. Okay, so that is the f of x function. And then let's do f inverse of x. All right. So what we can do is we're basically swapping. So it's really x is equal to 5y minus 3. That's the inverse, right? You swap the x and the y values. So this is this is the beauty of parametrics, is now when I want to find the inverse, I just need to do this. I need to set x equal to 5t minus 3 and y is equal to t. That's actually really sweet. I don't have to do anything. I don't have to solve for anything. I literally just swap the x and y, and the calculator is going to do it for us. Okay? That's really sweet. Okay, and then we have y equals x. And that, if I want to write as a parametric, that's easy. It's y equals t and x equals t because they both equal the same, so y equals x. Okay? So that's actually, this, math fans, is super significant when you're using parametrics. That is the beauty of parametrics, is if I want to find an inverse, I just need to swap the x and the y in the parametric equation. That's all I have to do. It's pretty easy. Okay, so let's go ahead and do this one. Let me move this over here a little bit. Okay, so bear with me while I type this in. So it's going to be y is equal to, well, I have to put it in parametric mode. So I have to go my mode. Okay, so now I'm in parametric mode, which is sweet. So the first one, x equals t, y is equal to 5t minus 3. Okay, then we're going to graph the second one is going to be x2 equals 5t minus 3. Y is equal to t. And then x equals t and y equals t. Okay, so now we're going to graph this baby. Zoom 6. And look at that, man, I actually graphed it pretty fast because they're all linear equations. Okay, that's it. You can see it. Okay, there's one graph. The y-intercept -3, so that's the y equals 5t minus 3, and then the x equals 5t minus 3 is this one. And there's y equals x. Okay, so that's pretty cool. So I can draw this in here. I don't want to waste your time either, but I'm going to do it in 3 different colors here. So I'll do the blue is the original function. Okay, so I'll put this in blue. And that one's in red, so I'll do the red one. That was this function. And then we'll do green for the other one. This is green, and so that's y equals x. And you can see it's symmetric. Okay, okay, cool. Okay, and moving on, we got a few more here to do. Okay, so we're going to do the f of x one first. That's going to be y is equal to 2 to the t plus 1, x equals t. And we'll do the inverse. And that's going to be x equals 2 to the t plus 1. Again, super easy, right? And y equals t. And then for the y equals x, same thing. Y equals t, x equals t. Okay, then you just put that in your graphing calculator. So x equals t, so 2 to the t plus 1, so 2 to the t plus 1, and then that's going to be 2 to the t plus 1 as well, so 2 to the t plus 1, and everything else should be the same. Oh, I have a -3 in here. That would mess things up a little bit. Let's get rid of that. Okay. Okay. And then we're going to do we're going to set the window actually. Otherwise, it's going to give us a crazy one. I did this one ahead of time here, and we just need to set it nicely. So if I do from -10 to 10, and that doesn't really matter for that. Oh, there we go. Okay, okay, and then -10 to 10. Okay, great. And let's go ahead and graph it. It's an exponential function. There's the other function, and there we go. Hey, that's cool. All right. So And I'm not going to spend time because it takes a long time. You guys can just draw this in the graph. It takes me a long time to change colors and everything but that's what the graph looks like. So go ahead and fill that in. And again, the first one, the first equation is the one on top. The second equation is the one on the bottom. Of course, you know y equals x. Okay, so that's pretty good. So let's talk about the domain and the range for this function because I think that's kind of important. So the domain of the original function, it could be, you guys could be any value you want, right? So I'm going to go negative infinity to positive infinity. And the range for that function, it basically can't be negative. It can be the smallest value. 2 to the negative 10 power is 0.0000, right? But it's positive. So it means it's going to be from 0 to infinity. And then you just need to swap these two. So it's going to be 0 to infinity and negative infinity to positive infinity. Okay, so that's the range of that. So let's actually go back to the graph then. So we'll just take a look at what it looks like. Do you guys agree that if you look at the first function here, which is the top function, it never goes to 0, right? As you go more and more left, it goes really, really close to 0, and then it gets really big, exponential, right? It goes up. And then you look at the one below it, and you can see how it kind of swaps those values, right? It'll never, the y value will go to negative infinity, but x value goes to 0. It doesn't get any smaller than 0. That's why you can see the domain and the range. They kind of swap. Values. It's kind of cool. Okay, it is good stuff. I like this stuff. Okay, let's look at number 7. So again, I'm just going to go pretty quickly here now. For f of x, we're going to get y is equal to 2 to the negative t minus 1 and x equals t. So inverse is going to be x equals 2 to the negative t minus 1 and y equals t. And of course, y equals x is going to give us y equals t and x equals t. Okay, so bear with me. In fact, I'm going to pause this and just type it in. Okay, I've got everything in, so let's go ahead and get graph. Okay, there's the first equation, second equation, and look at that, man. Oh, sweet. Again, it's, you know, if I did a zoom square, make it look a little bit better. Okay, pretty cool. Shows the symmetry there, and I just think it's kind of cool. Okay, so one last one, and again, I'm going to kind of pause this again while I type it in, but let's just come up with the equations. Okay, remember, equations are really easy to come up with, guys. They're really easy. So the one with the f of x, that's going to be y equals ln of t minus 3. And x equals t, and then the inverse is going to be x equals ln of t minus 3. So easy. And then y equals t. Okay, and then of course y equals x, x equals t, y equals t. Okay, so let's go ahead and put that in our graphing calculator. Again, I'm going to pause this while I type it in. Okay, I've got it typed in now, and let's go ahead and graph it. There's the first equation, there's the second equation, and there we go. There's the symmetry. All right. So it looks good. So anyway, I just want to show you on the graphing calculator, or really I want to show you how easy it is to come up with a parametric graph. If you ever wanted to look at an inverse graph using parametrics. It's really easy to come up with a graph. I can give you any graph and I say, hey, go ahead and find the inverse. And if you guys, again, look back 1 through 4, you had to swap the x and y, you had to solve to actually see what the inverse, and then to graph to see what the inverse is. But on 5, 6, 7, and 8, I basically said, well, you know what? If I just want to see what the graph looks like, I don't need to swap the variables and solve. I can just use parametrics. And that's one beauty of using parametrics is for inverses. That's like the best part. It's pretty cool stuff. Okay. Okay, so the last part of this is using the graphing calculator to solve for a variable. Now, a lot of you guys will look at number 9, you'll say, well, Mr. Curtis, I can just take the log of both sides and move the exponent down. I'm like, yeah, okay, you can. But I'm going to show you a different way to do it. Because number 10, you can't do that. Right? So what I'm going to do with this one is I'm going to actually move that 1216 over. I'm going to subtract 12.16 over, and I'm going to get y is equal to 2 to the 0.5 t plus 1 minus 12.16. Really, that's the equation. So basically what it is, I just subtracted this over, and it's equal to 0. Okay? And I know I put it into an equation because I need to actually enter it as an equation, but technically, here, let me just write this out here. It's 2 to the 0.5 t plus 1 minus 12.16 equals 0. This is really what I have here, math fans. Okay, I have it equal to 0. So I need to know how this can be equal to 0. That's why I actually set it equal to y, because I'm going to use my graphing calculator, and I'm going to use the graphing function, and I'm going to say, well, when is this equal to 0? And I have a 0 function on my calculator. So I'm going to actually get out of parametric mode. Don't be confused. I know I put it in terms of t, and I kind of did this on purpose. It could be x, t, whatever variable it is. You're going to get out of parametric mode. Okay, so go to your mode and cursor down to function. And I don't know if I even showed you in the beginning about how to graph. I probably didn't even show you parametric mode on this calculator because I've never even showed this before. Yeah, sorry about that. So if those, hopefully you figured this out and you saw, again, it's function and parametric mode. And hopefully you guys are good with that. Sorry about that. Didn't even realize that this is the first time showing it on the graphing calculator. Okay. All right, anyway, we're going to back to function, and then we'll hit y equals. And I'm going to clear this last thing out here. And I'm going to put in y is equal to 2 raised to the 0.5x plus 1. Make sure your cursor over minus 12.16. Okay, so I'm going to hit zoom 6. Show you what the graph looks like. Okay, so basically, this is what the graph looks like, and if you understand, I wanted to find out what's equal to 0, which if I set y equal to 0, which is right here, right where it's crossing the x-axis, that's going to give me the answer. So what I'm going to do is I'm going to hit second calculate. I'm going to use 0. Second calculate 2. And then you guys should know left bound. It's hard to see it on this one. Oh, there it is. Okay. So there's left bound, enter, and then right bound. Just make sure I cross the other side. Okay, enter, and enter. And there we go. If you look on the bottom here, y is equal to 0, and x equals, or in this case t, right, but it's x here, is 5.2081. So that's your answer. T equals 5.2081. Now you could have solved it with logs, no question about it, right? You did, and that's the way I would choose to solve it if I was given a problem like that, and it said you could solve it any other way. Okay, So let's move on to number 10, because 10, you can't actually solve that easily. Look at it. It's an exponential function, it's a linear function, and it's a log function all into one. How are you going to solve for, there's no way to solve for t. You can't take the log of both sides. It just doesn't work. So what I'm going to do, very simple, I'm going to subtract 2. So I have that equal to 0. So I'm going to do y is equal to 1.045 to the t power plus t plus log of t minus 2. Oh man, that's actually pretty sweet. So let's go ahead and put that in our graphing calculator. We can do that one together because that one's going to take a little bit of time here. Just a little bit. Okay, so let's do y equals, make sure you use lots of parentheses, 1.045 raised to the t. I probably didn't use parentheses there. So it's to the x, cursor over, plus t or x plus log of x, close that parenthesis, minus 2. Okay, so it's going to solve for t. It's kind of cool. So we're going to do zoom 6. So that's what the graph looks like. Okay, and then we're going to do second, calculate 0. And it's right there. So, okay, and then move to the other side. Okay, that's good enough. Enter and enter. Okay, and so you get t is equal to 0.9697. So t equals 0.9697. Okay, that is actually really cool. Okay, so you use your graphing calculator with the zero button. Okay, but it's got to be equal to 0, obviously, and then you use the 0 button. But I just want to show you because it kind of gets me all excited here. Let's just clear out of here because I want to show you how it works. I mean, of course it works. It's mathematics. Okay, so 1.045 raised to the 0.9697 plus 0.9697 plus log of 0.9697 minus 2. That should equal 0. And it does. I mean, I know it looks like it doesn't, but it's lots of decimal places. If you move it over 5 decimal places, it's 0.000055. So it's, of course I round it because it's 0.9697. That's cool stuff, guys. It's very, very cool. So understand that you need to be able to solve for any equation. I can give you any equation with logs, with trig, with whatever, and you just use the 0 button. You graph it and you use the 0 button and you solve for any variable. So anyway, math fans, that's it. Again, learning a little about inverse functions, learning about using parametrics to find inverse functions, domains and ranges, and also using calculator to solve for a variable for any function. All right, that's it, math fans. You have an outstanding day. Adios. Goodbye.